Hi everyone, I'm Thong Chun On. In this video, I'm going to present the paper, and the title is IoT-Based Contactless Body Temperature Scanning System for a Smart and Safe Campus. These are the outline that will be discussed in this video. Let me start with some general information on Internet of Things. IoT is the technology device with sensors, software, and other technologies which can connect and exchange data with other devices and systems over the internet. IoT has evolved in many fields such as domestic, industrial, environmental, military, biometric, transport, etc. Due to the outbreak of coronavirus disease, checking body temperature and recording personal details have become the new norm. Everyone requires to follow this standard operating procedure when arrive a new place. However, there are some problems occur when conducting this SOP. So, an IoT-based contactless body temperature scanning system is proposed in this paper to avoid the problems occurring in UTHM campus. There are 4 problems occurred when conducting the SOPs. Firstly, there is a close range between the worker and customer during the measurement of body temperature. So, they could be infected if one of them is a virus carrier. Secondly, checking body temperature and writing the personal details of customer are not able to conduct instantly. Although MySejahtera application was developed to enable people to record their data by scanning QR code, many people complain that the application is unresponsive and keep crashing. Next, the recorded data will be lost as the information of customer is recorded into a logbook. It is possible to be lost due to some reasons such as forgetting to take it back and being taken by an outsider. Lastly, the recorded data is not real or incomplete. Some customers rush and think that writing the details are wasting their time. So, they just write down their name in short form or leave it blank. The IoT-based contactless body temperature scanning system was developed to ensure UTHM campus is safe and reduce the risk of spreading the virus. It allows users to measure their body temperature and record their personal details without involving other people. Meanwhile, human resources can be reduced as no worker is needed to check people's body temperature. Moreover, users can upload their personal details without using a mobile phone as only an identity card is required. Lastly, the recorded data is saved into cloud storage, so the users and admin can check the previous recorded data through the monitoring website. Table 1 shows the summary of characteristics of some related works. From this table can analyze that the proposed system is better than the 3 existing systems due to some reasons. Firstly, an identity card scanner was designed to replace the face detection as users can record their personal details by scanning their identity card. Next, human resources can be reduced as no worker is needed to check people's body temperature. After that, the proposed system was not as complex as the 3 existing systems, so the checking process was fast and there will be no problem on the accuracy of body temperature measurement. Lastly, the proposed system also can be used as an attendance system as users required to check in and check out. Figure on the left is the use case diagram of the proposed system. There are 2 actors involved in this system, which are user and admin. Moreover, the functions of the system are listed, which are login, register, edit profile, check body temperature, scan personal details, view reports, update database, and delete account. While figure on the right is the activity diagram of the proposed system. From the beginning, the user has to scan his RFID card, which is an identity card of the user. If the scanning system does not detect the ID of the card, then the user is required to scan the card again. Once the ID of the card is detected, the user needs to check body temperature by closing his forehead to the contactless body temperature sensor. If the body temperature is between 36.1 degrees Celsius to 37.5 degrees Celsius, then the scanning system will emit a green light and a short beep sound. Otherwise, the scanning system will emit a red light and a long beep sound. After that, the data is recorded to the cloud storage. Finally, the body temperature and personal details of the user are displayed on the LCD screen. Next, figure on the left is the wiring diagram that shows the physical connections between the IoT components in the prototype. 6 components are included in the figure, which are Arduino Uno, RFID module, contactless body temperature sensor, LCD, buzzer, and LEDs. The connections between the components are shown by using different colors of line. And the figure on the right shows the hardware setup of the contactless body temperature scanner. Now, I will show the demo for the prototype of IoT-based contactless body temperature scanner. Hi, welcome to my system demo video. Now, I'm going to present how the contactless body temperature scanner is work. Once the hardware is on, the LCD shows a message to notice the user to scan his identity card. When the scanning is success, the RFID number is displayed and the body temperature checking is start. When the checking is done, the value and the status of the body temperature are displayed and the LED is light up. Then, the recorded data will be sent to the cloud database. Next, I'm going to present the monitoring website of the system. User is required to log in this monitoring website by using his user ID and password. If the user does not have an account, then he can register an account on the sign up page. In this sign up page, user need to fill this registration form to create an account. Once the registration is success, then he will be redirected to the homepage of the website. From the homepage, user details are displayed in table form. If user wants to edit his profile, he can click on the edit button to update his personal information. Once the update is success, the user details are updated. Then, user can view the previous record by clicking on the report tab on the navigation bar, and the recorded data is shown. For admin, he also can log in to the monitoring website by inserting his ID and password. Once the login is success, admin will be redirected to the admin dashboard. Next, admin can view all the recorded data in this website. Admin also can perform CRUD action, which are create, update and delete action within this website. For example, by clicking on the Create tab, admin can make a new report by inserting the information. Admin also can edit the data by clicking on the pen icon. If admin wants to delete certain data, he can click on the trash icon to delete the selected data. The bar chart illustrates the result of user acceptance testing for IoT-based contactless body temperature scanning system. 4 participants were found in the Parit Raja area to do the testing and provide feedback for the developed system. Based on the bar chart, all the respondents were satisfied with all the aspects of the developed system. However, 2 respondents gave average feedback on the acceptance requirement number 4, which was the system is able to emit light and sound. Moreover, there were no respondents found not satisfied with the acceptance requirements on the developed system. For the accuracy testing, it was conducted to compare the accuracy between the developed system and standard device. Table 2 shows the result of accuracy testing for the developed system. Based on the average accuracy for all the experiments, the temperature values of the standard device were slightly different, as the same device was used for these 5 experiments. For the proposed system, the temperature values were different in the experiments, but almost the same with the temperature values of the standard device. Therefore, the accuracy of the proposed system was roughly the same as the standard device. In conclusion, this paper proposes an IoT-based contactless body temperature scanning system for a smart and safe campus. The proposed system helps users to measure their body temperature and record their details without interaction with other people. The proposed system was successfully implemented and ready to be deployed. The average accuracy of the proposed system was 99.86% compared to a standard device. In the future, the system will need to be improved in terms of the time it takes to upload data to the cloud and the implementation of additional features to the monitoring website. Lastly, the authors would like to express their thanks to University Tun Hussein All Malaysia for support. This research is supported by University Tun Hussein All Malaysia through Tier 1. And these are the references for this paper. That's all from me. Thank you for watching this video.